Welcome to this video in which I'll be solving the UCI Math 2A sample file number 1. This is on the department's website. So those of you that have been on my channel for a while might have seen this video before, but I'm just resolving it once more and I'm going to break it up into two parts instead of one long video. All right, so let's dive right in. Number 1, for what value of a is this function continuous at every x? Okay, so we want it to be, it looks to be discontinuous at 3, so we want to make it continuous. This is a classic type of problem where we had to find the limit. Okay, well, let's recall what the definition of continuity is, first of all. We want it such that limit as x approaches to 3, that's where it's piecewise, so that's why we want to approach at 3, f of x. We want it to be f of 3 for it to be continuous. So let's find what this limit is first. What's the limit from the left? So that's the 3 minus notation of f of x. This is, it'll be 3 squared, which is 9. Okay, and we take the limit from the right. So that's the 3 plus notation. Okay, so that would be what? That would be 2 times a times 3, which is 6a. Okay, we want the limit from the left to equal limit from the right. So why do we want to do that? Well, we want this limit to exist. So that's the condition. Limit from the left has to equal limit from the right. So we set 9 is equal to 6a. So we simply get a is 9 over 6, which is 3 over 2. Okay, that's how we solve this one, as simple as that. Theory of relativity predicts that an object whose mass m0 when it is at rest will appear heavier when it is moving at speeds near the speed of light. When the object is moving at speed v, its mass m is given by m is m0 over square root of 1 minus v squared over c squared, where c is the speed of light. Find dm dv and explain in terms of physics what this quantity tells you. Okay, I really don't like these type of problems because they, well, this one especially because you can interpret this in a few different ways, but we'll try to think through what this grader or whoever wrote this test is trying to get us to write. Okay, so let's differentiate this first of all. That's probably the majority of the points, or that's half the problem. So let's differentiate. m0 is constant, c is a constant, because the mass doesn't change, the actual mass of the object, and the speed of light doesn't change. They're constants. So let's find dm dv. So, well, first of all, we can even write this as m0, 1 minus v squared over c squared to the half power. We could write it like that, sorry, negative half power. So we can use the power rule there, and then the chain rule will be minus m0 over 2 times 1 minus v squared over c squared to the negative 3 half power times derivative inside, which would be minus 2v over c squared. Okay. So we get this when we differentiate. I feel like this is good enough, but we can clean up a little bit. So 2 negatives make a positive. This 2 can cancel with this 2. So we can rewrite it as 0 times v over c squared times 1 minus v squared over c squared to the 3 half power. Okay, so this is the derivative. All right, so what does this tell us? So this is why this is not a good problem. Whoever wrote this did not do a good job, in my opinion, because we can interpret this. They probably want us to interpret it in terms of m and v, but you can say a lot about this equation because there's so many variables. But let's keep it simple. Let's just say that the mass increases as the velocity increases. Okay, why do we know that? Well, as v gets bigger, dmdv gets bigger, which is the change in mass, right? So the mass is, dmdv is positive, so the mass is increasing. Okay, we can keep it simple like that. Once again, I don't think that they wrote this problem well for them to grade it well and to grade it fairly, in my opinion. Let's move on. I have it back actually over here. Show that the equation, this guy has exactly one root. Okay, this is going to take a while maybe because we have to use multiple theorems. Okay, so how can we first approach this? Well, what theorems do you learn in this class? You learn things like intermediate value theorem, Rawls theorem, mean value theorem. Which one can we use? Let's first do intermediate value theorem. Actually, that's a problem later in the test also to state what it says. So what does it say? We need it for this problem. Remember, we say there's a simple case where if the function is continuous, there's some positive point, there's some negative point on some interval a and b, then because it's continuous, it has to cross the x-axis at least once. So there has to be a zero. So it can look like this, it can look like this, or it can even oscillate a few times, right? So it has to cross at least once because it's continuous on the interval a to b, okay? So let's first show that this is continuous. Let's say f of x is equal to 3x plus 2 cosine x plus 5, okay? We know this is continuous everywhere. F is continuous for all real x. We have to write this. I don't know an easy way to show it, but I can just tell you that, well, we know that 3x is continuous everywhere. 2 cosine x, that's continuous everywhere. 5 is continuous everywhere, so f is continuous everywhere. It's for all real x. All right, so we said that now we can use intermediate value theorem. So let's try to find a point where it's positive and a point where it's negative. So let's pick an easy point. Let's say f of 0. Where is that? Well, what is the value? That would be 0 plus 2 plus 5, which is positive, okay? So let's find a negative point. You don't get a calculator, so you got to try some number. Let's try easy number. So I'm thinking, well, this is big plus 5, so let's try some value of x that's negative so that we can make this negative and maybe this cosine negative also to bring it down. Okay, so I'm thinking let's make it like negative pi. Okay, so this would be negative 3 pi minus 2 plus 5, okay? We know this is less than 0. Why do we know that? Well, 5 minus 2, that's 3, that's easy. 3 minus 3 pi, pi is about 3.14, right? So let's round down to 3 even. So 3 minus 3 times 3, which is 9. So 3 minus 9, that's negative 6. So that's a negative number, okay? So since we found one point is positive, another point is negative, and since f is continuous everywhere, then by intermediate value theorem, there is at least 1 0 on the interval negative pi to 0. Okay, so I wrote it in interval notation. All right, so we found that there's at least 1 0. How do we show there's exactly one real root? Okay, so remember the motto in this class that I've said in previous videos? When in doubt, take a derivative. All right, so let's find f prime. And I'll explain why I want to do this in a bit. So f prime would be 3 minus 2 sine x, okay? Why do I want to do this? Well, I know that sine x, this whole term, actually, let me go with that, 2 sine x is between 2 and negative 2. Why do I know that? Sine x is between 1 and negative 1. Okay, you should know how that looks. So 2 sine x is just between 2 and negative 2. So this guy, because it's 3 minus 2 sine x, the smallest value it can take, or to make this 3 minus 2 sine x, the smallest value it will ever be would be when 2 sine x is 2. So it'll be 3 minus 2, which is 1. So 1 is always greater than 0. So, okay. So we can say since f prime greater than 0 for all x, f is always increasing. And if f is always increasing, then it can only cross the x-axis once. So there's only one real 0. So let's write that down. Okay, so that's how I would solve this one. Okay, let's move on. Hyperbola is given by this guy. Use implicit differentiation to find an equation of the tangent line to this curve at the point 1, 2. Okay, so let me double check the focus of this camera. Is that better? I think it's a little better. Okay. I apologize if it was not as clear before. So implicit differentiation, let's do it. Derivative of x squared is 2x. Derivative of 2xy is 2x dy dx plus 2y. Okay, I did the particle first, d second. So first, I put 2x as the first term. D second would be dy dx plus second would be y. D first, derivative of 2x, just 2. Okay. So next, derivative of negative y squared is negative 2y dy dx. Derivative of x just 1. Derivative of 2 is just 0. Okay, so we can solve for dy dx here and then plug in the point later. I like to just plug in the point now so that it might simplify some of the terms. Okay, so let's do that. X is 1, y is 2. So it'll be 2 plus 2 dy dx plus 4 minus 4 dy dx plus 1 is equal to 0. Okay, this would get us 7. So it would be negative 7 on this side. This would give us, what, negative 2 dy dx. So dy dx is 7 over 2. This is the slope of a tangent line. We have a slope, we have a point, we can find the equation. Point slope form, y minus 2 is 7 over 2, x minus 1. That's the answer. It doesn't say you have to put it in slope-intercept form, so I wouldn't spend extra few seconds. You could do it if you want. It's a few extra seconds, not that hard. I would just come back to it later and do it, though. But technically they didn't ask for it, so this is correct as well. Little Susie is enjoying a nice spherical lollipop. She sucks the lollipop in such a way that the circumference decreases by 1 cm per minute. So we can say dc dt is minus 1. Okay. How fast is the volume of a lollipop changing? So we want dv dt. When the lollipop has a radius of 5 centimeters, r is equal to 5. Okay. So we want to find dv dt. Let's find v first. What's the equation of the volume of a sphere? 4/3 pi r cubed. So we differentiate. dv dt would be 4 pi r squared dr dt. We have r. We don't have dr dt though. So we have to use dc dt to find our dr dt probably. So c is 2 pi r. It's a sphere, so the circumference would be a circle. So dc dt is 2 pi dr dt. And we said dc dt is negative 1. Well, we didn't say it. They give it to us. So dr dt is minus 1 over 2 pi. Okay, so now we can plug it in here. So we have 4 pi, r is 5, so 25. dr dt is minus 1 over 2 pi. Okay, we can simplify. That is minus 100 over 2, which is negative 50. And we need units though. This is change in volume over change in time. So it would be centimeter cubed per minute. Okay, that's how we solve that one. Find the linear approximation of this guy at the point A is 16. Okay, linear approximation is the exact same thing as tangent line. Okay, so let's find the equation of the tangent line. X is 16. Okay, so find the slope of the tangent line, we need f prime. So that would be 3 over 4 x to the negative 1/4 power. We evaluate at x is equal to 16. So that would be 3 over 4 times, well, 16 to the 1/4 power is 2, because 2 to the 4th is 16, but it's to a negative exponent, so it'll be 1 over 2. So that's 3 over 8. Okay, this is slope. We need the points. So the point would be 16 comma f of 16, which is equal to 16 comma, when x is 16, we plug in here. So we said 16 to 1/4 power is 2. 2 cubed is 8. So we have a slope, we have a point, we can find the equation. That's y minus 8 is equal to 3 over 8 x minus 16. All right, and then the linearization, L of x, I believe that's how they notate it. You just find y and replace y with L of x. I think that's it. So it'll be 3 over 8 x minus 16 plus 8. Okay, that's how we solve this one. Okay, I'll probably finish this page and call it a part. We have, I think I have an old version of the test. This f of 3 is 4. Let me double check. Yes, f of 3 is 4, g of 3 is 2, f prime of 3 is negative 5, g prime of 3 is 6. Find these. So this one is just, we use properties of derivatives, by the way. It'll be f prime of 3 plus g prime of 3. What is that? That is negative 5 plus 6, which is 1. This one is product rule. It'll be first. We start first, d second, plus second, d first. That's the product rule. So this would be what? F of 3 is 4, f prime of 3 is 6, plus g of 3 is 2, f prime of 3 is negative 5. Okay, so this is 24 minus 10, which is 14. So that's the answer there. And this one is quotient rule. So bottom, d top, minus top, d bottom, over bottom squared. So what is that? G of 3 is 2, f prime of 3 is negative 5, right? Minus f of 3 is 4, g prime of 3 is 6, over bottom squared, g of 3 is 2, 2 squared is 4. Okay, so this is minus 10 minus 24 over 4, which is minus 34 over 4, which we can simplify, minus 17 over 2. Okay, so this is just testing your rules for differentiation properties. Find the absolute max and min values of this function on the interval -1 to 2. So let's find out if there's any local max min first by the first derivative test, and then we have to check the endpoints, okay? So f prime is 12x cubed, we're just doing power rule, minus 12x squared. We can factor out 12x squared actually. We're left with x minus 1, okay? We set it equal to 0. So our critical points are x is 0 and 1. Do our first derivative test. We can even restrict the interval like this, because we only are interested in this interval, okay? So we plug in a number on this interval, like -½ Well, this guy's always positive. -½ minus 1 is negative. We plug in some number like half, over here, this guy's always positive. Half minus 1 is negative. We plug in some number here, like 1.5. This would become positive finally. Okay, so we know that there is a relative min over here, okay, because the derivative changes from negative to positive. This one doesn't change sign, so there's no minimax there, okay? So we have to check our endpoints, as I said, f of -1. We have to check f of 1, that's the relative min, and the absolute max would probably be f of 2, because it's decreasing and then it increases finally over here, okay? So actually we don't know it. That's why we have to check this endpoint also. It might not increase as much as how this started, okay? So if that makes sense, let me find these. So f of -1, we plug into here. That would be 3 plus 4, which is 7. How about f of 1? That would be 3 minus 4, which is -1. How about f of 2? That would be 3 times 16 minus 4 times 30, sorry, 4 times 8, which is 48 minus 32, which is 16. Okay, so we can clearly see that f of 2 is the absolute max, whose value is 16. The absolute min is that x is 1, whose value is -1. So we say absolute max is at 2, 16. Absolute min is at 1, -1. Okay. So for value, you could just say technically 16 and -1, that's okay, okay? But I would just give the whole coordinate so that you can probably get full credit. But technically it's asking for value, so technically it's just 16 and -1. All right? Okay, so I'll call it a part here. Please give this video a like if you found it helpful, and please subscribe to look out for the next parts.